Next is question number 71, where we have to find the domain of the function f(x) equal to log to the base greatest integer of mod sin x plus mod cos x, greatest integer of 2 times mod sin x plus mod cos x. Right. Now we know that for log to the base a, b, a should be greater than 0, a should not be equal to 1, and b should also be greater than 0. Now, if the base is greater than 0 and it should not be equal to 1, as it is a greatest integer function, we can directly say that mod of sin x plus mod of cos x, its greatest integer cannot be equal to 0, cannot be equal to 1. Its greatest integer can take the value from 2 onwards, which means that mod sin x plus mod cos x should be greater than equal to 2. Now we know that this is never possible. So we can say that the domain of the function is phi, that is empty set. So answer will be option number 1. Now let's discuss question number 72, which says that the number of solutions of the equation signum of sin inverse x equal to fractional part of 2x is. A very simple question. See, on the left hand side we have a signum function which can take the values -1, 0 or 1. And on the right hand side we have a fractional part function which can take only integral value as 0, which means that for solution to exist both should be equal to 0, that is x equal to 0 is the only solution. So number of solutions of the equation will be 1, that is option number 2 will be the correct answer. Next is question number 73, which says that the value of 4 times tan inverse 1 by 5 minus cot inverse 239 is equal to. Right. Firstly, let's find the value of 2 times tan inverse 1 by 5. We know the formula of tan inverse a plus tan inverse b, that will be equal to tan inverse a minus b upon 1 plus ab. Right. So this will be equal to tan inverse 2 by 5 divided by 1 minus 1 by 25. So this is equal to tan inverse multiplying by 25 in the numerator and denominator. We will get 10 upon 24, that is equal to tan inverse 5 upon 12. Now talking about 4 times tan inverse 1 by 5. So that will be equal to 2 times tan inverse 5 upon 12. So this will again be equal to tan inverse 10 upon 12 divided by 1 minus 25 upon 144. So multiplying by 144 in the numerator and denominator, we will get it equal to tan inverse 120 divided by 144 minus 25, that is 119. So we have to find the value of tan inverse 120 upon 119 minus cot inverse 239, that can be written as tan inverse 1 upon 239. So solving this further, again tan inverse x minus tan inverse y, it will be equal to tan inverse 120 upon 119 minus 1 upon 239 upon 1 plus 120 upon 119 into 239. So solving this, we will get it equal to tan inverse 1, that will be equal to pi by 4. So answer will be option number 2. Next is question number 74, which says that the number of solutions of the equation sin inverse 2x minus cos inverse x plus tan inverse 2x equal to pi by 2 is. A very nice question from inverse trigonometric functions. Let's solve it. See, we know the graph of sin inverse 2x. It is something like this. Also, now the graph of minus cos inverse x, it will be like this. So this is the graph of minus cos inverse x and this is sin inverse 2x. Now talking about tan inverse 2x. Tan inverse 2x, that is also like this. Right. Firstly, finding the domain of the function. We know that 2x will go from minus 1 to 1, which means that x will go from minus half to half. So this is the domain of the function. So if we add all these three functions, we can see that the minimum value will be obtained at x equal to minus half and maximum value will be obtained at x equal to half, right? So at x equal to minus half, value of sine inverse 2x minus cos inverse x plus tan inverse 2x will be equal to sine inverse minus 1, that is minus pi by 2, minus 2 pi by 3 minus pi by 4. So this will be equal to minus 17 pi divided by 12. Also the maximum value that will be obtained at x equal to half. So that will be equal to sine inverse 1 minus cos inverse half plus tan inverse 1. That is equal to pi by 2 minus pi by 3 plus pi by 4, which is equal to 5 pi by 12. So we can say that the range of this function is from minus 17 pi by 12 up till 5 pi by 12. Now it can be seen that pi by 2 is greater than 5 pi by 12, which means that there will be no solution of this equation. So number of solutions will be 0, which means that option number 1 is the correct choice. Next is question number 75, which says that consider a function fx equal to sine inverse sin x. So we have to find the values of all these. So let's firstly plot the graph of sine inverse sin x. That is something like this. Where this value is pi comma 0, this value is 2 pi comma 0 and this value is 3 pi comma 0. This is pi minus x, this is 3 pi minus x and this is x minus 2 pi. So f of 2 will be somewhere here. So f of 2 is pi minus 2. So option number 1 is incorrect. F of 3 is somewhat here. F of 3 will be pi minus 3. So this is also incorrect. F of 7 will be somewhere here. So value will be 7 minus 2 pi. So this is also incorrect. Now f of 9 will be somewhere here. So f of 9 will be 3 pi minus 9. So option number 4 is the correct answer.